everyone, welcome back to the channel. In today's video, I'll show you how to install a new Seaborn in Jupyter Notebook. If you love data visualization, Seaborn is a must-know Python library. It makes stunning graphs with just a few lines of code. So let's get started. Now let us see what is Seaborn. So Seaborn is a Python data visualization library based on Matplotlib. It provides high-level interface for drawing attractive and informative statistical graphs, and Seaborn works great with pandas data frames, making it easy to explore and analyze datasets visually. So let us install Seaborn in Jupyter Notebook. So for that we need to first open Jupyter Notebook either from Anaconda or from the command prompt. Then after opening the Jupyter Notebook, for installing Seaborn we need to write pip install Seaborn. So the exclamation sign at the beginning tells Jupyter Notebook to run a shell command. So we can see that requirement is already satisfied, which means that it is already installed in my system, but still we can verify the installation by importing Seaborn and checking its version. So for that what we need to do is we need to import Seaborn, and we can import it as SNS, which is a shorthand for Seaborn, and then we can print its version. Print SNS underscore underscore version underscore underscore. Now let us see what is the version of Seaborn in my system. So it is 0.13.2. So this means that Seaborn has been successfully installed. Now let us see how to deal with some common installation issues. So if you get an error that pip is not recognized, then you can try using -m pip install Seaborn. Or if you get an error that there is no module named Seaborn, then you need to ensure that it is installed in the correct environment by running import sys sys.executable mpip install Seaborn. And finally, if you're getting an error that Seaborn graphs are not displaying in Jupyter Notebook, then you can add this line before plotting %matplotlib inline. Now let us do data visualization in Seaborn. So for that we need to import the required library, that is Seaborn. So in the above step we have already done that, so I'll not be writing that code again. And then what we need to do is we can load a sample data set. So Seaborn comes with built-in data sets. So let me load the famous tips data set. So for that what I'll do is I'll create a variable df, and I'll write the code sns.load dataset, and in that I'm loading the tips dataset. And let me see the first 5 rows of the dataset. So instead of loading a sample dataset, we can also load our own dataset using for that first we'll have to import pandas as pd, and then we can use df is equal to pd.readcsv, and then we can write our own file path name. So instead of that I've just loaded a sample dataset tips, and in tips what we have is we have the first column is total bill, the second is tip, then we have the sex, male or female, then we have smoker, yes or no, then we have the day, then we have time, and then we have size. There are several ways to draw a scatter plot in Seaborn. So the most basic, which should be used when both variables are numeric, is the scatter plot function. The scatter plot is the default kind in rel plot, and it can also be forced by setting kind is equal to scatter. So let me plot a scatter plot. So for that what I can do is I can either write sns.scatterplot or I can write sns.relplot. So relplot basically stands for relational plot. So in that I am taking data from df, and in the x-axis I want my total bill, and in the y-axis I want tip. Yes, so we can see that a scatter plot has been plotted between total bill and tip, which shows the relationship between these two variables. Now what we can do is that in this one the points are plotted in 2 dimensions, so we can also add another dimension by coloring the points according to a third variable. So in Seaborn this is referred to as a hue semantic because the color of the point gains meaning. So what I'll do is I'll again write sns.rel plot, then I'll again take data from df, and in the x-axis I'll again take total bill. In the y-axis I'll take tip, and in hue I'll take smoker. So we can see that again a scatter plot has been plotted between total bills and tip, but in this we have added another dimension, that is whether the person is a smoker or not. So the blue points show that the person is a smoker and the orange points show that the person is not a smoker. So to emphasize the difference between the classes and to improve accessibility, we can use a different marker style for each class. So for that I'll again write sns.relplot. In data I'll again take df, in x again the total bill, y will be tip, hue is again smoker, and in this I'm adding style as smoker. So what is the difference between this plot and this plot is that in this the smoker was differentiated based only on the basis of color, blue or orange, but over here the color is also different and the marker style is also different. So for smoker we have a blue circle, and for a non-smoker we have an orange cross. Now it is also possible to represent 4 variables by changing the hue and style of each point independently. But this should be done carefully because the eye is much less sensitive to shape than to color. So what I'll do is I'll quickly plot. Again data is df, x is total bill, y is tip, my hue is again smoker. Now the style is time. Yes, so what is now I have plotted total bill versus tip. These are 2 dimensions, and over here there are another 2 dimensions, that is smoker and time. So for smoker we have the colors. For yes it is blue, and for no it is orange, and for the time, for lunch it is a circle, and for dinner it is a cross. So this one shows that the person is a smoker and the time is dinner time, and this one shows that this person is a non-smoker but the time is lunch time. So in the examples above, the hue semantic was categorical, so the default qualitative palette was applied. So if the hue semantic is numeric, the ring switches to a sequential palette. So for that what I'll write is sns.rel plot, data is df, x is total bill, y is tip, and my hue is size. So we can see that it's a scatter plot between total bills and tip, and in this the hue is based on the size. So we have from 1 2 3 4 5 6. Now let us explore some more Seaborn plots. So first let us explore the line plot. So for that I'll write is sns.lineplot. X is size, Y is total bill, and my data is DF. So we can see that we have generated a line plot between size and total bill. So we can see that as the size increases, total bill is also increasing, which makes sense. Now let us plot a histogram, which is also called a distribution plot. So for that what I'll write is sns.histplot. Total bill and let me use 20 bins. KD is true. So this is a distribution plot. So it follows a normal distribution curve. So we have like the maximum count we have in the range of 10 to 20, and as the bill size increases, the count also decreases. Now next, let me show you a box plot which is used for outliers, for basically for outlier detection. So I'll write sns.boxplot. In X let me take day, in Y let me take total bill, and data is DF. So this is my box plot, and these circles above shows the outliers. So on Friday we have the least outlier, and on Thursday we have the maximum outlier. So that is how easy it is to create stunning visualizations with Seaborn.
And that's it. Now you know how to install and use Seaborn in Jupyter Notebook. If this helped you, smash that like button and subscribe for more Python and data science tutorials. Drop a comment below if you have any questions. See you in the next one.